The European Space Agency released the data from ExoMars camera on one of its orbiters of Mars. It looks like they detected the interstellar visitor, 3I Atlas.
An object from another star system just past Mars. And what this scientist discovered has completely shattered everything we thought we knew about comets. The interstellar visitor, the 3I Atlas that entered our solar system in 2025, is not behaving like any comet we've ever studied. It has broken all the fundamental laws of physics as we understand them.
And looked rather anomalous. The object is quite large, and it's also aligned in its path with a plane of the planets around the sun.
A jet of material shooting toward the sun instead of away from it. No dust tail, no ice sublimation, and an orbital path so perfectly aligned with our planetary system that the odds of it happening naturally are virtually impossible. And now the conclusion is stunning. This thing is not a comet. But if it's not a comet, then what exactly is it? And why does it seem to be aimed directly at us? The discovery that has left us puzzled.
Of the wow signal and 3I Atlas are aligned. Chance probability of 0.6%.
To understand why Avi Loab is willing to stake his reputation on this object, we need to go back to July 1st, 2025. The 3I Atlas survey telescope in Chile was running its standard asteroid detection protocol, scanning the southern sky for potential Earth threats, when something extraordinary appeared in the data. At first glance, it looked like another routine detection, but when astronomers calculated the trajectory, they realized they were looking at something that had traveled across the vast universe between star systems to reach us. This was 3I Atlas, the third confirmed interstellar object in human history. Now, most objects that drift into our solar system from interstellar space should be small, dark, and probably nothing beyond what we've seen in recent years. But 3I Atlas appeared surprisingly with a bright glow. Even more puzzling was its path. Rather than tumbling through at some random angle like you'd expect from a natural object, 3I Atlas was traveling nearly perfectly aligned with the flat plane where all our planets orbit the Sun. Think about that for a moment. The odds of a random chunk of ice and rock from deep space happening to line up so precisely with our planetary system are roughly 1 in 500. It's like throwing a dart from a moving car on the highway and hitting a bullseye 2 miles away.
Moving so fast at 60 kilometers per second, that's 600 times the fastest race car that we have on Earth.
This level of precision is what first caught Avi Loab's attention. But the real bombshell came on July 21st, when the Hubble Space Telescope captured detailed images of the object. What scientists saw shouldn't exist according to everything we understand about cometary physics. Every single comet humanity has ever studied follows an ironclad rule. When solar radiation heats their surface, they release gas and dust that forms a tail pointing away from the sun. This happens because the solar wind, that constant stream of charged particles flowing outward from our star, pushes the material away like leaves being scattered by a powerful fan. But 3I Atlas broke that rule. The Hubble images showed something extending from the object's nucleus, but this feature was pointing toward the sun instead of away from it. Multiple teams of astronomers immediately began checking and rechecking their data.
The richness and the complexity of the data, it's all there. The universe is like sort of hiding in the darkness and we have to bring it out.
Convinced they'd made some kind of processing error. Different telescopes observed from different angles. They adjusted for perspective, accounted for motion blur, ran simulations. Every single analysis came back with the same impossible result. The 3I Atlas was displaying what researchers now call an anti-tail, a sunward-pointing jet that defies conventional cometary behavior. Well, this is exactly what made Avi Loab sit up and take notice. As the head of Harvard's Galileo project, an initiative specifically designed to search for evidence of extraterrestrial technology, Loab had been tracking 3I Atlas since its discovery. But the anti-tail changed everything. In his words, the existence of a glow ahead of 3I Atlas but no evidence of gas molecules is puzzling. It doesn't make sense for a natural object. The scientific community tried to explain it away. Some suggested it might be an optical illusion caused by the viewing angle. Others proposed unusual dust properties or asymmetric outgassing from a rotating nucleus. But when the Keck 2 telescope in Hawaii turned its powerful instruments toward 3I Atlas in August, it confirmed what Hubble had seen. Clear evidence for a puzzling anti-tail extension in the direction of the sun. This wasn't an illusion. It was real. And this was just the beginning of 3I Atlas's anomalies. Because as astronomers continued observing this interstellar visitor, they discovered something even more disturbing. The shocking chemical anomalies.
The comet's path will take it past even more of our robotic explorers.
In late September 2025, researchers using sophisticated spectrographic instruments made a discovery that would escalate the 3I Atlas mystery to an entirely new level. They detected nickel in the material being released from the object. Now, comets do contain trace amounts of various metals, but here's the problem. They found nickel without corresponding amounts of iron. You see, in natural cosmic environments, nickel and iron always appear together in specific ratios. They're created by the same stellar processes, condensed from the same protoplanetary disks, and remain chemically bonded throughout a comet's lifetime. Separating nickel from iron requires industrial processing, the kind of purification techniques we use here on Earth to create specialized nickel alloys for spacecraft heat shields, turbine blades, and other high-performance applications. But the nickel-to-iron ratio observed in 3I Atlas is a characteristic we only find in industrially produced nickel alloys. These are materials designed for extreme thermal environments, the kind of conditions you'd encounter if, say, you were building something meant to withstand the intense radiation environment near a star. To help you understand how unusual this is, imagine finding a smartphone buried in a layer of sediment from 200 million years ago. The components might individually occur in nature, but finding them arranged in integrated circuits with that level of precision and purpose, that would indicate intelligent design, not natural processes. The nickel signature from 3I Atlas presents a similar paradox. But the chemical anomalies don't stop there. The James Webb Space Telescope, using its infrared instruments capable of detecting molecular signatures invisible to optical telescopes, revealed that 3I Atlas has a carbon dioxide to water ice ratio of 8:1. That number might not mean much to you, so let me put it in context. It's among the highest ratios ever recorded for any comet, natural or otherwise. Most comets in our solar system have ratios closer to 1:1. Maybe 2:1 at the extreme. 8:1 is literally out of this world, according to Northeastern University's Professor Jacqueline McCleary.
That's mind-blowing to think about. Again, it's astronomical. These aren't things that we normally encounter in daily life.
This extreme ratio tells us something profound about where 3I Atlas formed. Carbon dioxide ice, what we call dry ice, is extremely volatile. It sublimates, transforming directly from solid to gas at much lower temperatures than water ice. For a comet to maintain such a high concentration of carbon dioxide relative to water, it must have formed in an environment significantly colder than the regions where most comets originate. We're talking about temperatures found only in the outer reaches of stellar systems, far beyond what we see in our own solar system's comet reservoirs. Now here's what makes this particularly intriguing from Loab's perspective. An object with this chemical profile should have started outgassing much earlier in its approach to our Sun. Carbon dioxide begins sublimating at incredible distances from stellar heat sources. Yet 3I Atlas remained relatively dormant until it was already deep into the inner solar system. This delayed activation doesn't match the thermal models we have for natural comets with this composition. Loab asks the rather obvious question. What if the carbon dioxide isn't the primary component but rather a coating, a thermal shield of some sort? If you wanted to protect something as it journeyed through interstellar space for potentially billions of years, and then entered the hostile radiation environment near an alien star, a thick layer of carbon dioxide ice would make an excellent insulator. It would ablate slowly, providing cooling through sublimation, while protecting whatever lay beneath. And there's more. Recent observations detected cyanide in the outgassing material. Again, not unheard of in comets, but the pattern of release is strange. The cyanide appears in both the forward-facing jet toward the Sun and in the more traditional tail pointing away from it. This suggests multiple venting mechanisms operating simultaneously. Natural comets typically show chaotic, asymmetric outgassing driven purely by solar heating of a rotating, irregular nucleus. The dual-direction venting seen in 3I Atlas implies something more structured, more controlled. Loab has been accused of sensationalism for suggesting these observations point toward artificial origins.
With a relatively modest deflection relative to its original direction of motion.
But when you lay out this evidence systematically, you start to understand why he created his eponymous scale for rating potential technological artifacts, and why he ranks 3I Atlas at a 4 out of 10. But the most controversial aspect of it all isn't what 3I Atlas is, it's what he believes it might do next. The impossible trajectory. First, let's talk about speed. When 3I Atlas entered our solar system, it was moving at 58 kilometers per second relative to the Sun. That's hyperbolic excess velocity, the speed an object maintains after escaping the gravitational influence of our star. To put that in perspective, the first interstellar visitor, Oumuamua, arrived at 26 kilometers per second.
And this time, the usual follow-up measurements of position and speed showed something completely different.
The second, Comet Borisov, came in at 32 kilometers per second. 3I Atlas is moving nearly twice as fast as its predecessors. Now, why does this matter? Because the faster an interstellar object travels, the older it likely is, and the farther it's come. Based on stellar population studies, researchers estimate 3I Atlas could be between 7.6 and 14 billion years old. That potentially makes it 3 billion years older than our entire solar system. This thing was already ancient when Earth formed. 3I Atlas's orbital eccentricity is 6.137. For reference, a perfect circle has an eccentricity of 0. Earth's slightly elliptical orbit has an eccentricity of 0.0167. Anything above 1 is a hyperbolic trajectory.
The goal of this video is to provide an intuitive understanding of essential components of hyperbolic orbits,
meaning the object will escape the solar system permanently. But 6.137? That's so extremely hyperbolic that the path appears almost perfectly straight rather than curved. It's shooting through our solar system like a bullet through tissue paper,
making a beeline towards our solar system. The object was initially named A11PL3Z.
Yet despite this incredible velocity, the trajectory aligns within 5 degrees of the ecliptic plane, that flat disk where all our planets orbit. Loab has calculated the probability of this occurring naturally, and it's approximately 0.2%, 1 in 500. For an object that's supposedly been drifting randomly through the galaxy for billions of years, that's an extraordinary coincidence. Unless it's not a coincidence at all, then there's another factor to suspect here: the timing. 3I Atlas's path brought it close to Mars on October 3rd at a distance of just 29 million kilometers. It will pass within 54 million kilometers of Jupiter on March 16th, 2026, and during its closest approach to the Sun, which happened on October 30th, it was positioned directly behind our star as viewed from Earth, completely unobservable from our planet during the most crucial phase of its journey.
Only over the past decade we started finding interstellar objects. It's a new frontier. We don't know if we were visited before.
Loab calls this remarkably convenient for something that might not want to be closely observed. He's proposed what he calls a black swan scenario, an event with low probability but enormous implications. What if 3I Atlas isn't simply passing through our solar system? What if it's using what's called an Oberth maneuver? To help you understand an Oberth maneuver, imagine swinging around a pole on a rope. As you swing past the pole at high speed, any force you apply gets amplified because you're moving so fast. In spaceflight, this means firing engines at the moment of closest approach to a gravitating body gives you maximum efficiency for changing trajectory. It's how spacecraft gain extra velocity to reach distant destinations.
In their paper, is the interstellar object 3I Atlas alien technology?
Now, if 3I Atlas performed an Oberth maneuver during its passage behind the Sun, when no Earth-based telescopes could observe it, it could have significantly altered its trajectory. It could have gained velocity, changed direction, or entered a different orbital path, all while completely hidden from our view.
Because if it does a maneuver around the Sun, that would show it's not a natural object, right?
Yes, it will be a technological signature.
Loab is careful to state that he assigns 3I Atlas only a 30 to 40% likelihood of having not fully natural origins. That's still less than half. He's not claiming certainty, but he's arguing that the implications are so profound that even a small probability must be taken seriously. This is where his 4 out of 10 ranking comes from on his scale, measuring potential extraterrestrial technology. Most scientists dismiss this speculation as irresponsible sensationalism. NASA's Tom Statler put it bluntly, "It looks like a comet. It acts like a comet. It's a comet." But Loab has never been deterred by mainstream criticism. In fact, his willingness to consider unconventional explanations is exactly why his voice matters in this debate. But there's one more piece of evidence that mainstream astronomy is trying very hard to ignore. The Mars encounter nobody's talking about.
Its path doesn't seem to be affected at all. Some scientists think this unusual behavior.
October 3rd, 2025 should have been the most important day in interstellar object research. That's when 3I Atlas made its closest approach to Mars, sweeping within 29 million kilometers of the red planet. Multiple advanced spacecraft were perfectly positioned to capture unprecedented observations. The European Space Agency's ExoMars Trace Gas Orbiter, Mars Express, and potentially others operated by NASA and the Chinese Space Agency. This was the opportunity astronomers had been waiting for since July. Spacecraft orbiting Mars could observe 3Y Atlas continuously without atmospheric interference, capture images from multiple angles, and gather detailed spectroscopic data about its composition and behavior. So what did we get?
Telescopes around the world have tracked this Manhattan-sized object.
A handful of fuzzy images showing 3I Atlas as a slightly fuzzy white dot against streaked star fields. The official explanation is that the imaging systems on these Mars orbiters are designed to photograph the bright surface of Mars from just hundreds or thousands of kilometers away, not a relatively dim target 30 million kilometers distant. The cameras simply weren't optimized for this kind of observation. It's technically true, but to many researchers, including Loab, it feels like a missed opportunity of historic proportions. Or perhaps it wasn't missed at all.
This is especially convenient for an orbiter, as it is moving around the planet anyway.
NASA's Mars Reconnaissance Orbiter carries the HiRISE camera, one of the most powerful imaging systems ever sent to another planet. With a half-meter diameter mirror, HiRISE can resolve features as small as 30 centimeters across on the Martian surface. When pointed at 3Y Atlas during its Mars flyby, this instrument should have captured images with resolution measured in kilometers, potentially revealing surface details, structural features, or other characteristics that would definitively determine the object's nature. NASA confirmed that HiRISE successfully captured observations on October 2nd. The data was transmitted back to Earth. Scientists processed the images, but then something unusual happened. The images were not released to the public. Now, in fairness, there was a legitimate reason for the delay.
Also, Earth is now moving in the opposite direction relative to the comet, which makes it even harder to see against the bright background of stars.
The October perihelion passage meant that 3I Atlas was reaching its closest approach to the Sun right when it disappeared behind our star from Earth's perspective. The optimal time for analysis and announcement would be after perihelion, when the object emerged from solar conjunction and became observable again in November. There's a reasonable argument for waiting until you have the complete picture before making announcements.
ESRO had made some decent progress, but ELDO wasn't doing so hot.
The European Space Agency was more forthcoming with their Mars orbiter observations, releasing the fuzzy white dot images relatively quickly. But these images, while scientifically valuable, don't show much detail. They confirm 3I Atlas was where calculations predicted it would be. They show a diffuse coma, consistent with a comet. They reveal nothing that would settle the debate about its nature. Meanwhile, the highest resolution images ever captured of an interstellar object remain locked away in NASA databases.
Well, yes, because there is limited reservoir of rocky material per unit volume in interstellar space.
Loab has called for the International Asteroid Warning Network to officially monitor 3Y Atlas. This network, usually reserved for objects that pose potential impact threats to Earth, has now designated 3I Atlas as its first interstellar target. They've announced an observation campaign running from late November through January to gather detailed astrometric measurements and improve trajectory predictions. But here's the question nobody in the mainstream wants to address. Why does an object that poses no threat to Earth, according to NASA's official statements, require monitoring by our planetary defense network? What are they really preparing for? What happens next?
Also, Earth is now moving in the opposite direction relative to the comet, which makes it even harder to see against the bright background of stars.
As of late October 2025, 3I Atlas is currently behind our Sun from Earth's perspective, but will emerge into the pre-dawn sky around November 11th. giving telescope users their next chance to observe this enigmatic visitor. And this is where Loab's scenario either proves true or collapses entirely.
And just when many thought it was a normal comet.
If 3I Atlas is a natural comet, as the vast majority of astronomers believe, it will continue on its calculated hyperbolic trajectory, gradually fading as it moves away from the sun's warmth. The outgassing will decrease. The coma will dissipate. The object will grow dimmer and eventually disappear into the darkness between stars, never to return. Case closed. But if Loab is correct, if this object has any technological component whatsoever, then the period immediately after perihelion represents the moment of truth. Did it perform an Oberth maneuver while hidden behind the sun? Has its trajectory changed in ways that can't be explained by gravitational influences alone? Will it continue behaving in ways that defy conventional cometary physics? The December 19th closest approach to Earth offers our best observation window. At 1.8 astronomical units, approximately 270 million kilometers, 3Y Atlas will be near enough for ground-based telescopes to potentially resolve surface features and gather detailed spectroscopic data. Amateur astronomers worldwide are preparing to contribute observations, creating a distributed monitoring network that can provide continuous coverage. But the most scientifically valuable encounter is still months away. On March 16, 2026, 3I Atlas will pass within 54 million kilometers of Jupiter. NASA's Juno spacecraft, in orbit around the giant planet since 2016, carries instruments capable of resolving features just kilometers across. If the orbital mechanics work favorably, and if NASA decides to point Juno's cameras at the passing visitor, we could get the closest, most detailed images of an interstellar object ever captured. The European Space Agency's JUICE mission, currently en route to Jupiter, may also be positioned to observe 3Y Atlas. ESA has announced they'll attempt observations in late November, after the object has passed perihelion and entered its more active state. However, because JUICE is using its main antenna as a heat shield while near the Sun, it's operating at reduced data transmission capacity. We won't receive results from JUICE's observations until February 2026. These upcoming observations represent more than scientific curiosity. The International Asteroid Warning Network's decision to monitor the 3I Atlas, their first interstellar target, suggests that someone, somewhere in the planetary defense community, is taking the possibility of anomalous behavior seriously. They're not saying it publicly. They're not endorsing Loab's speculation, but they're watching closely. And that should tell you something. Now, Loab has been careful to state repeatedly that he believes 3Y Atlas appears most likely to be a natural comet. He's assigned a 30 to 40% likelihood of non-natural origins. That means he thinks it's probably natural. But he's also saying there's a very real possibility, roughly 1 in 3, that humanity is currently being visited by something artificial from another star system. Those are remarkable odds for a Harvard professor to put on record. His critics will say he's hedging his bets, setting up a scenario where he can claim vindication either way. If it's natural, he predicted that as most likely. If it's artificial, he was one of the few brave enough to consider the possibility. But Loab would argue that this is exactly how science should work, assigning probabilities based on available evidence, updating those probabilities as new data arrives, and remaining open to unexpected conclusions.
That's the way science is done. We shouldn't assume we know the answer about its nature in advance. It's a blind date of interstellar proportions.
The truth is, we're in an unprecedented situation. Never before has an interstellar object arrived with this many anomalous characteristics. Never before has humanity had the technological capability to study such a visitor in this much detail. And never before has a prominent mainstream scientist been willing to publicly entertain the possibility that what we're seeing might be more than a natural phenomenon. So what does all this evidence actually tell us? The final verdict. Let's be direct about this. It is confirmed that this object exhibits behavior unlike any other comet we've studied. The anti-tail pointing toward the sun remains unexplained by conventional cometary physics. The chemical composition, particularly the nickel-to-iron ratio and extreme carbon dioxide concentration, falls outside normal parameters for solar system objects,
allowing nickel to outgas, while iron remained bound in the nucleus.
The trajectory alignment with the ecliptic plane represents a statistical anomaly that demands explanation. In that specific sense, 3I Atlas is not behaving like the comets we know, but does that make it artificial? Does unusual equal alien? The scientific consensus remains firmly that the 3I Atlas is a natural object, just one that's teaching us how much diversity exists among interstellar comets. Every observation so far, while unusual, can be explained by natural processes if you're willing to accept that comets from other star systems might differ significantly from those born in our own cosmic neighborhood. Yet Avi Loab's position deserves serious consideration, not because he's necessarily correct, but because of what's at stake if he is. The discovery of extraterrestrial technology would rank among the most significant events in human history. It would fundamentally alter our understanding of intelligence in the universe, our place in the cosmic order, and potentially the trajectory of human civilization itself. Given those stakes, Loab argues, we have a responsibility to investigate thoroughly rather than dismissing possibilities out of hand based on prior assumptions. And he's right about that.
I was disappointed. I would have been much more excited if we have found evidence.
Even if his specific interpretations prove incorrect, the coming months will be decisive. As 3I Atlas emerges from behind the Sun and becomes observable again, as it passes Earth in December and Jupiter in March, we'll gather enough data to either explain the anomalies through natural mechanisms or confirm that something deeply unusual is happening. If the object continues displaying its anti-tail,
Ice on a natural comet, given that speed, we can tell that there is a lot of mass.
if the chemical signatures remain anomalous, if there's any evidence of trajectory alterations that can't be explained by gravitational forces and normal comet behavior, then Loab's ranking of 4 out of 10 on his technological artifact scale might need to be revised upward.
For now, I rank it 4 on the scale that I define that is called the Loab scale, where 0 is a natural object.
But if 3I Atlas gradually transitions to more typical cometary behavior, if the sunward jet disappears or reverses direction, if the outgassing patterns normalize as solar heating increases,
By these jets so that they can penetrate through the solar wind about 5 billion tons.
then this will go down in history as an unusual but natural comet that briefly captivated public imagination. Either way, we're living through a remarkable moment in astronomy. An interstellar visitor has arrived, displaying characteristics that challenge our models and force us to question assumptions. Professor Avi Loab, whether proven right or wrong, has ensured that we're asking those questions openly rather than assuming we already have all the answers. Because sometimes, the most important thing science can do is admit there are things we don't yet understand, and keep watching the skies until we do.